Hi, I'm Abraham and welcome to my React series. In this first video, we'll be covering components, what they are and what role they have in React applications. After that, we'll move on to JSX, which is the markup we use for writing our components. There, we'll learn the main features of JSX as well as the rules we need to follow when writing JSX. That said, let's get started with our first topic. In this first example, we start off with an app that renders a list of items. Now, this app is very static, and it only renders a list of items. In web development, static just refers to fixed content that doesn't change unless we manually make changes. What this means is that if we wanted our app to render a different output, we would have to update our index.html file. However, when we open our second app, we get introduced to some interactivity. Now, this is a counter app that allows the user to increment a counter. This app is dynamic because it allows the content to change based on our user's input. We'll also notice that our app now includes a JS file. And in this JS file, we're basically just grabbing the elements that we need in our application and assigning those elements to variables. Also, we are defining a count variable that starts from 0. Then, we define a function that increments our count variable by 1 and then updates the content of our p tag as follows. Finally, we add an event listener to our button that calls our predefined function whenever the button is clicked. And just by linking our static HTML file to this dynamic JS file, we made an app that's dynamic and interactive. And as more and more applications include features like this that require interactivity, it would make sense to just stay dynamic and only add static HTML when needed. And this is exactly what React does with components. When we return to our first app that renders a list of items and turn on the React panel, we'll first notice that our application is built from a function that returns the output of our application. When we take a closer look at the return value of our function, we can see that our list of items is now being mapped from an array of elements. If we wanted to change the output of our application, we will still need to modify this JS file. However, there are many benefits to using functions to handle logic and return markup. To better understand this, let's discuss functions and their role in JavaScript. In JavaScript, functions are these blocks of code that can be defined to perform a specific task. This task could be as simple as returning the sum of two numbers, as we see in our first example, or it could involve a series of events. Once a function is defined, it becomes reusable, allowing us to use it multiple times with different inputs. If a function has parameters in its definition, we can generate various outputs by assigning different values to these parameters. You can think of these values as additional instructions we provide our function when calling it. If we didn't provide any values, the function will work with what it has. For example, if we call our sum function without supplying values for its parameters, the output will just be not a number. This means that even though we didn't provide extra instructions, the function still operated based on its available instructions, resulting in the addition of nothing to nothing, which isn't a valid number. If we wanted to avoid the not a number output, we can simply assign default values to the parameters in the function definition. This way, the function will know what to do when no values are provided for its parameters. React components are designed to be reusable UI building blocks, which are both functional and structural. Now let's go through why functions are perfect for achieving this. First off is reusability. Functions are inherently reusable. Once they are properly defined, they can be called with different inputs multiple times, generating different outputs. For instance, consider the greeting function. It takes a name parameter and returns a greeting message with the provided name. By calling this function with different names, we see different output each time. If we later decided to change the greeting message to like good morning, we would only need to modify the function definition, and the change would apply everywhere we call our function. Secondly, we have functionality. Components gain their functionality through logic, and functions provide access to logic, which offers tremendous flexibility. We can literally incorporate various logical instructions just before we return our component. Additionally, we can use JSX to insert logic directly into the part responsible for structuring our component. And lastly, we have structure. In web development, structure is defined by HTML. Functions can achieve this by returning HTML. However, there's a more dynamic markup called JSX, which we'll cover later. But for now, all we need to know is that JSX enables us to embed HTML-like code directly into our JavaScript. And there you have it, the three main reasons why functions are perfect for creating components. Now that we have a better understanding of functions, let's revisit our example and open up the React panel of our first app. As explained in the previous section, the sole purpose of components is to serve as reusable UI building blocks. Let's see how we can achieve this by taking a look at our first app and going through its JSX file. We start off by defining a component as a function. This function returns a special markup called JSX, which allows us to write HTML-like syntax right inside our JavaScript code. For this app, we use JavaScript to loop through an array of elements and perform a task of returning a list item tag for each element in the array. And this provides the output that we see on the right side. When we open the JSX file of our second app, we'll see that it follows the same process, even though it's slightly more advanced than the first one. We first define our component as a function, and then we furnish it with instructions for incrementing a counter when a button is clicked. Much like in the vanilla JS panel, we begin by setting up our count variable, starting it at 0, and after that, we define the function that's responsible for handling the increment. Then, we add a conditional expression into our return statement, stating that if the count is 0, the first p tag should be returned. Otherwise, we should return the second p tag with the current count value. And finally, we add an event listener to our button by giving it an onClick attribute with the value of our predefined function. And there you have it, a counter app. Now that we've covered both of the apps, we can move on to our next example, which introduces a component that's a bit more advanced. In this example, we have a layout component being used to build up a website of multiple pages. The component itself is highlighted with purple and shows a couple of sections that seem to be part of every page on the website. These sections include a header, a sidebar, and a footer. However, the third page is the only page that doesn't have a sidebar. This might look complex at first, but in reality, this component is following the same steps we used to create the components in the previous example. Remember, the components are just functions, and once we define our functions, we can reuse them as many times as we want. And each time we use our functions, we can return a different output by providing our functions with extra bit of instructions. Let's see how this is done by going through our layout component. First off, we define a component by giving it instructions for rendering the different sections we see in each page of our website. However, because every page looks different, we need to set parameters that we can later assign values to when calling our function. Remember that parameters are just there to give our functions access to that extra bit of instructions we can later on add when calling our function. This is great for our layout component because every page is actually a different calling of the same function. What I mean by this is that each call just provides different instructions for the content that we want to be rendered. The way we handle these instructions can be determined in our function definition. That's all there is for this component, really. Even though it's more advanced than our previous components, it follows the same principles. And by doing so, we get an awesome looking layout component like the one we have here, and where each page is constructed by the same function but still look totally different from each other. If we ever wanted to change the layout of our website, we'd only have to do that change in one place, and that change would apply in every page. This is because every page is just calling the same function. For the last example of this topic card, we'll go through the syntax we use when creating our components. The creation process is pretty simple as it involves only 3 steps. First, we export the component. In this export statement, the export default prefix is a standard JavaScript syntax and it doesn't come from React. It just makes the main function of our file available to use in other files. As shown in the app.jsx file below, we can use our exported component by importing it. Because this is a default export, there are a couple of things to consider. The most obvious one is the syntax of our import statement. To show this, let's change the export type to a named export. Now, we see that the import statement introduces a set of curly braces that wrap our component. But when we use a default export, the curly braces disappear. The second thing to note with default exports is that these exports can be imported with any name you choose. This is because default exports are meant to provide a single default value from a file, and the name of that file is not fixed by the file itself. However, named exports must be imported using the exact names they were exported with. Now let's go through defining our function in the second step. In the highlighted syntax, we define a JavaScript function with the name example. React components are regular JavaScript functions, but their names must start with a capital letter or they won't work. If you're wondering what the three dots here stand for, they're just there to symbolize the markup we'd add to our function. And this brings us to the third and final step. In this step, we see a return statement that takes care of adding markup. Remember that the markup we use is JSX, which allows us to write HTML-like code inside our JavaScript functions. For demonstration purposes, we've left out the actual JSX part and just symbolized it with three dots. And the parentheses in our return statement are just there to allow us to write our markup on multiple lines. If we wanted our return statement on one line, we'll just leave out the parentheses and write our markup right after the return keyword. After adding our markup, our function is now ready to be used. Now that we've discussed the core basics of React components, we've also developed a better understanding of their purpose and role in our applications. Next up, we'll go on to JSX, which is the markup we use to write our components. We've already been introduced to JSX, so going through the following examples will be very easy to understand. Let's open our topic card to go through the first example. In this first example of our JSX section, we'll learn the different features of JSX by going through these 4 different apps. Our first app renders a greeting followed with the user's name. In the source code, we can see that the user's name is being stored under a variable called name. Below our variable, we have the JSX code that represents the output of our application. Let's see what happens when we change the value assigned to the name variable, which currently has a value of John. As we can see in the output window, the greeting message updates when we change our name value. This is because our name variable holds any value we assign to it. By doing so, we can get this value by referring to our name variable. But to do so, we'd have to be in a JavaScript environment. So when referring to our variable in JSX, we can use curly braces to open our code to JavaScript. These curly braces, highlighted here in purple, are really just windows into JavaScript. And once these windows are open, we can write code as if we were in a JavaScript file. Just like with functions, we can define variables once and reuse them in our code. Let's continue to the second app to see how versatile these curly braces can be. Our second app is another greeting app. However, our greetings are rendered based on a condition. We can see this by toggling between the Boolean values we assign to our variable. Like in the previous app, we first define a variable that holds a value. This time, the value that it holds is of type Boolean, and it starts with true. Then in the JSX part of our code, we see a conditional expression. The syntax we see in this expression is from JavaScript, so we need to wrap our code with curly braces. This expression is basically saying the following. If the isLoggedIn value is true in a Boolean context, then return the first p tag. Otherwise, return the second p tag, and that's it. To summarize, this expression starts with the condition and returns the first value after the condition if the condition is true. Otherwise, it returns the second value. Let's open up our third app. Now we see a list of items being rendered. Like in the previous apps, we see the JavaScript part of our code being coded inside the purple curly braces. This time, we're using JavaScript's built-in method to loop through an array of elements and perform a task for each element. The task for now is to return a list item that has the following properties. A key attribute with the value of the element in the array, and a text content with the value of the element in the array. This expression produces the output we see on the right. 4 elements in an array renders 4 list items, each item displaying the value of the element inside the array, which is just a number. Now let's see what happens when we remove a list item. This makes sense because the output is dependent on the expression we see in our curly braces. Also, if we ever wanted to change the task of our map method to do something else, like returning a h-tag with a different text content, we'd only need to modify our expression in one place, and the change would apply to every element in the array. Now let's move on to our final app. In this app, we see how JSX deals with event handling. Here we have a simple app that shows an alert message when the Click Me button is clicked. In the code section, we see that JSX allows us to add event listeners as attributes on our button element. After that, we can provide our handleClick function as a callback function to the onClick event, because we want to call this function whenever our button is clicked. Because JSX allows us to do this with JavaScript, we can just wrap our handleClick function in curly braces. Note that in the curly braces, we are only referring to our function and not calling it. This is because we want our function to only run when our button is clicked. We don't want our function to run when our button is rendered. And that completes the main features of JSX. I hope that with these examples, you've seen just how versatile JSX can be. Although JSX comes with a bunch of cool features that allows us to write dynamic markup, it also comes with 3 important rules that we should always follow when using JSX. In our next example, we'll go through these rules step by step and explain the reasoning behind them. The first rule tells us to return a single root element. Let's refresh the preview window to see what this means. Right, so when our component is returning more than one element on the same indentation line, our syntax gets highlighted with red, indicating an error. In HTML and HTML-like syntax, indentations are these consistent spaces we have after our return statement. When two elements are indented by the same amount, they are aligned on the same indentation line. In JSX, the root element is always on the leftmost indentation line right after the return statement. JSX doesn't allow us to have more than one element on this line. The reason to this is that JSX elements are actually JavaScript objects. Remember that JSX is not understood by browsers and needs to be converted to regular JavaScript. This is why our components don't actually return HTML, but instructions to building the HTML for our components. And these instructions are stored in JavaScript objects. In JavaScript, you cannot return two objects from a function without wrapping them into an array. This is also why we cannot return two JSX elements without wrapping them into another tag or a fragment. And fragments are just these special JSX elements that let you group elements without leaving any trace in the browser's HTML tree. What this means is that if we only wanted to render an h1 tag and a p tag, as shown in the preview window, we'll do so by replacing our div tag with empty tags. In JSX, empty tags refer to fragments. Let's move on to the second rule. This rule is very straightforward, and it instructs us to close all tags. Let's refresh the preview window to see what is meant by this rule. First, our tag is opened because it has a / missing in our closing tag. This will cause an error because JSX wants us to close all tags. Once we add a /, our error disappears. In this last rule, we get introduced to some casing convention. This convention is for formatting and styling the names of our variables, functions, and other identifiers. Let's refresh our preview window to have a closer look at what's actually happening. We start off with our style property, border radius, and class attribute being written by using a dash symbol and excluding a word, respectively. This will cause an error, but when we modify our syntax a bit to follow a camel case convention, we see our errors disappear. When writing in camel case, words are written together and each word, except the first one, starts with an uppercase letter. No spaces or punctuation marks are used. Camel case is really just the convention we use in JSX, and that's why JSX instructs us to camel case most of the things. This rule is also because of the limitations JavaScript has on variable names. For example, in JavaScript, variable names can't contain dashes or be reserved words like class. And there you have it, the rules of JSX. By following these rules, we ensure that the transpilation process from JSX to JavaScript goes smoothly and our apps get compiled correctly. And that completes our last topic. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell to stay updated with more coding tutorials. Thanks for joining, and see you in the next one.